Good morning, F period. Hopefully you guys are doing well and that you like my avatar and purple hoodie. Um, yeah, so let's talk about what you guys are going to work on today. Let me share my screen. Okay. This avatar is kind of freaking me out, so let's actually done. Here we go. Got my ugly mug here. All right. So let's talk about what you guys work on today. So you're going to be in a core unum. I believe I put a sign out in the front door of our classroom. And I'll shoot you guys an email as well. So you guys are going to be doing another activity, and you're going to be learning how to graph the sine function, or y equals sine x. So that's what we're going to be graphing today. I'm not going to do the whole thing with you, but you should read the little story here just so you know what's happening. So you're on a ride. It's like a Ferris wheel, as you can see right here. And it's called the Screamer. The reason it's called the Screamer is that you board the ride at ground level right here, but like a typical Ferris wheel, which, goes up high in the sky and back down again. This actually goes underneath the ground. And I guess this goes to some dark, scary pit or something like that. So that's kind of the story here with it. The radius is 100 feet. That is important. That's relevant to what we're working on today. And every seat on the ride is separated by 15 degrees on a circle because this is circular. So you can think of like an arc in a way. So that's your task. The right function describes how far above and below or below the platform a rider is when the screamer breaks down. And I guess this ride does break down. So you'll be on it and it'll break down. You might be up high in the sky, or you might be down below in some dark pit. So there'll be some cereal boxes with circles and a skewer to put through the circle here. And the circle will be labeled ready for you with degrees, and it'll go in increments of 15 degrees, goes from 0 to 360. So, your sub, we'll have two subs because you're going to be combining classes. You'll be have Senora Lasala from the World Language Department and Ms. Langston. Obviously, Ms. Langston will steer the ship here because she's a math teacher. But she'll kind of guide you of how to set this up. So make sure you give her your full attention, that you're focused and sitting next to the people you're supposed to be sitting next to. In terms of how to actually do this, what you're going to do is you're going to rotate or you're going to focus on a particular angle on the circle. For example, let's say we look at 15 degrees. So you're going to have your zero box like this. We'll have a circle. And we'll look at 15 degrees. And you're going to have some sort of, not a zip tie, but like a pipe cleaner as the radius that goes from the center of the circle. So you'll tie it to the skewer. The skewer will go to the center of the circle. And you'll measure the length of the radius from the center to where you see 15 degrees. So you're going to want to measure that. I think it's about 80 something millimeters, if I'm not mistaken. It might be like 82 or 83, 84, 85, something, or 81. I don't know, something like that. But yeah, you'll have that. And then your job's to use proportional reasoning to figure the actual height of the screamer. So when you're at 15 degrees, and actually, let me take that back. The radius is about 80, not the measured height in the model. Sorry, my apologies. The radius will be about roughly 80 millimeters. But the true radius, of course, is 100 feet. So that should be feet, not meters, by the way, for the true radius. Okay, when you measure it, I can't remember what it was when you measure it. I think I'm going to kind of cheat here and use my calculator. Let's see here. Yeah, I think it was about 24 millimeters. And what you're measuring is this, the height. You're measuring it from the top of the cereal box. Let's use a different color. The top of the cereal box to where it says 15 degrees on your circle. So we'll call this h, the measured height. So it's going to be roughly about 24 millimeters. You're going to use a ruler to measure that. So then what you're going to do is you're going to set up a proportions like so in triangles, 24 over, say, 80. So these are your measurements. And these are in millimeters, by the way. You're going to compare it to the actual. So the actual radius is 100 feet, and you're going to solve for x. And that's what you're putting in this third column is the value of x. And if I do that using these assumptions, I should get about 30 feet. And you can do this for a variety of angles. I would suggest that you guys, you're not going to be able to do all the angles on the circle. It's just too much. But my suggestion is that after you do the measurements and do the proportional analysis to figure out the actual height, um, 30 degrees, 45 degrees, 60 degrees, 75 degrees, 90 degrees, kind of get the first quadrant out of the way. Then I would say 120, 135, 150, and 180. Then you could probably do maybe 210, 225, 240, 270, then jump to 315 and 360. Obviously, we're at 180 and 360, you'll have no height, right? Because the radius is right at the circle. Sorry, the radius is right at the box, where the box is. Sorry, it's a little early in the morning here. Well, not too early, I'm just a little groggy. Anyhow, but like for 30 degrees, if you're going to measure that, so you take this circle here, you move your radius to 30. Like, let's say you get stuck when it's at 30 degrees. That's a little high for 30. But okay, we'll go with it. Ah, what the heck did I just do? There's that again. So say that's at 30 degrees. So your goal is to measure that height from the top of the box, or the zero box right here, to where 30 degrees is. Measure that height. I think it's going to be about 30 or 40 millimeters. I can't remember exactly. Actually, it's about 40, I think. And you can set up another proportion. The measured height to the radius of your circle that you measure with the pipe cleaner. And then the actual is 100 and solve for x again. So you can do this calculation repeatedly. So maybe with working with a partner, one person could do the measurement and another one could do the calculations. So you can do a bunch of calculations here. Should take a few minutes. Once you do that, you're going to ignore the second column. Just focus on the first and third columns. And you're going to plot that on the next page. And you should be able to generate a plot that looks kind of like this. Like the first point will be at 0, 0, because you have no height. And you're gonna have like, some data points kind of like this. And it's gonna hit its peak at 90 as it should, because you're at the top, and get back down to 180. And then you're gonna have a bunch of negative values down here. Now, to do the measurements that are below that more than 180, because now you're below the box, so you can count as a negative measurement, just so you know. So you can count as a negative measurement, and that's then column anything past 180, because now you're in that dark pit. You're underneath the box, or underneath where the slit is for the box. There's some other things that you could answer here, which I think should be pretty self-explanatory. The last bit is the calculator part, and then you can work on homework after that. For the calculator part, let me pull this up. Give me one sec here. Just go to y equals sine x. Easy peasy. Hit second window. No, sorry. Second window, my bad. You want to start the table at 0. So it'll be 0 degrees because your x is degrees. And 15. And keep it on auto. Hit second graph. It's going to generate all the different values you should get for sine. And this will, oh, gotta switch to mode. My bad. the degrees. I know it looked a little off. Okay, well, hold on. Then let's try it again. What? Hold on. Okay, try again. Yeah, there we go. But actually, let me do 100 sine x. Okay, so I'm struggling here, guys. 100 sine x, because that's the actual equation we're working on. Because that's what you're going to do in the worksheet. You're going to, for part B, you're going to try to come up with the equation. Because remember, if you're actually on the ride, the radius is 100 meters, and that's theta, and that's a height. So height's going to be, or sine theta is h over 100. So h is 100 sine theta. Okay. So that's what we're going to actually graph. But let's do the table. There we go. So these are values you should be getting for the third column. If 15 should be about 25.8, 50. And if you plot these points, you should get a nice sine curve. And actually, I could update this if I go from 0 to 360, negative 100 to 100. And that's what we're just trying to understand today, how the sine curve is generated. Okay, I think that's pretty much it. After you're done watching the video, get to work, and I will see you guys on Tuesday. Have a great weekend, stay dry, and I'll talk to you guys soon. Goodbye.